The Salton Sea is a very exciting place if you're a geologist because it sits on top of the boundary between the Pacific Plate and the North American Plate. We have fault lines that are moving side by side. We have extension in that area where things are being pulled apart, and so we wind up with this unique situation of a trough that's below sea level that has been filled by the Salton Sea. Because of this lowering of the area, the magma is now much closer to the surface than you would expect, and consequently we have a lot of heat and gases that are being given off from the material below the surface. According to the U.S. Geological Survey, an active volcano is one that has erupted in the last 10,000 years. The Salton Buttes saw an eruption 1,800 years ago. So it is definitely classified as an active volcanic source.
I was a development geologist during the construction of the Salton Sea's first commercial geothermal power plant. Back then, I worked for Unocal Oil, which was a progressive oil company. Unocal wasn't just drilling for oil, they also owned Molycorp, which is a company that mined rare earth minerals, and they had a major investment in geothermal energy. One of our first challenges in working at the Salton Sea was to define the large reservoir of hot geothermal brine as close to the surface as possible. We brought in drilling rigs and drilled a number of test wells, production and injection wells. It's important to know that a geothermal reservoir isn't a big pool or cavern under the ground. The brine is completely absorbed within porous rocks that look like this. One of our challenges was to build the geothermal power plants and the well fields to allow the existing surface owners, such as agricultural companies, to continue to do their farming. So we had to have our operations so that both sides could coexist. We also drilled a number of monitoring wells that would monitor the pressure and temperature of the reservoir over time to ensure that we were not depleting it faster than we had estimated.
The world faces a perfect storm. We need cheap, renewable electricity sources to help us deal with the climate events that are happening and to help us address the rising consumption needs of the globe for electricity. And if we don't get that from something besides fossil fuel energy sources, it's game over. At the same time that we're trying to reduce the use of carbon or fossil fuels, we need more electricity. We need it to power electric cars. We need it for air conditioning. The rising temperatures are going to dramatically increase the demand for air conditioning everywhere. And third, with the water shortages that we're facing in many places, like the current drought in the west of the United States, we need desalination plants. And they are only cost effective if electricity is cheap.
Man, I really love the Salton Sea if you're here at the right time. Early morning when the sun's just coming up, the mountains in the background, the bird life, the pelicans, the cormorants. It's really a special place. And then there's the fact that the Salton Sea is where we have so much geothermal activity that we're able to generate some of our own electricity with geothermal plants. And there's the possibility that we can extract lithium out of the superheated brine that's underneath the Salton Sea.
One possible additional benefit from the investment in geothermal would be the potential we would get to learn more about how to extract important metals like lithium.
Well, it's true that the Salton Sea reservoir brine contains an abundance of valuable elements, including lithium, along with gold and zinc, silver, and a number of other compounds. There isn't a defined process to extract those yet developed. And so you have to have a process that will allow you to take that out, and the process has to be cost effective given the changes of those commodities over time.